on the reference angle. And the adjacent side also depends on the reference angle. Okay, so like in this case, if this is theta, if this theta is your reference angle, remember I told that the Greek letter theta is used to represent the value of an angle. Okay, this theta it will be equal to angle C. So angle C is equal to what? To theta. Okay, later we can also put x here. But generally for trigonometry, you need to get used to Greek letters. So if this is your reference angle, the side opposite the reference angle is called the opposite side. Then the other side, okay, which is next to the reference angle, this one is not the hypotenuse, this one here, it becomes your adjacent side. If angle A is the reference angle, it means BC becomes the opposite side and AB becomes the adjacent side. Okay? The hypotenuse does not change. It's only the adjacent side and the opposite side because they depend on the reference angle. Okay? So the ratios, like for example, opposite over adjacent, it has got a name. Okay? The ratio opposite over hypotenuse, it has got a name. Adjacent over hypotenuse also has a name. Okay? Now, the three trigonometric ratios in full, the first one is called sine, S-I-N-E. Now, this one here, when you write it as a shortcut, it becomes sin or sine. Okay? On your calculator, it's written as S-I-N. And that's the most common notation used for sine. Now, sine, okay, is defined as the opposite side divided by the hypotenuse. Okay? Don't worry, I'm going to write it down. Okay? The ratio of the opposite side over the hypotenuse is called sine. Then you also have cosine. Okay? Cosine, the abbreviation used is cos, C-O-S. Okay? And if you divide the adjacent side of any right angle triangle by the hypotenuse, you get the ratio which is called cosine. Okay? And then the third one is tangent. Now this one, it has got a relation with gradient, but for this grade, we won't want to get into the details of gradient. It is actually equal to the opposite side, which is the vertical distance, like in this case here, this will be the opposite side, divided by the adjacent side. And the shortcut for this is TAN, tan. Now, if you take out your calculator, you are going to see these three, sine, cos, and tan. Okay? Right. So, with reference to this triangle, the ratio sine, we use the shortcut as I said. So if I say sine of theta, it means theta will be the reference angle. Which side is opposite it is going to be AB. So your sine of theta, it will be always equal to the opposite side divided by the hypotenuse. And always remember that the opposite side depends on the reference angle. Okay, the reference angle is the one which determines which one of the two other sides is your opposite side. Once you identify your opposite side, means the third side becomes the adjacent side. Because the hypotenuse is constant. The hypotenuse does not change. Okay? And then we have got cosine of theta is equal to the adjacent side equal to the adjacent side divided by the hypotenuse. Okay? And then we have tan theta, which is equal to the opposite side divided by the adjacent side. Okay. Now, generally we use acronyms for this, or we just use some simple abbreviation. Sine theta is equal to O over H. Cos theta is equal to A over H. Tan theta is equal to O over A. And then we can come up with an acronym which makes things easier to memorize the three trigonometric ratios. So these two, okay, so these two, both of them have got the hypotenuse as a denominator. Okay? And the other thing which is very important is that we can use acronyms. This S here, that O, that H, we can end up having the word SOH. Okay? Then we have got that C, that A, that H. So we can have tau. And then this T, that O, and that A. If I use capital letter, that will be TA, to be to be TOA. Okay, which is pronounced, okay, when people say it, it's called Sokatoa. Okay, it's not the only way of remembering the three trig ratios. There is also Chashotao. Okay. If you start with cos, pay attention. Pay attention. Your C is this C. The H is that H. The A is that A. Then you can have shock. The S, this one here is that. The H is that. The O is that. And then you're going to have tau of it. Now this one, when you are naming it, in terms of ratios, you start from the right hand side. This one here, you start from the left hand side, going in that direction. Now you can choose now which one you prefer. Sokatoa, which is the most common one used, or you can use Chashotao to help you to remember the three trigonometric ratios. They are not given, the formulae are not given in examinations or tests. So you have to memorize the three trig ratios. Yes, the three trigonometric ratios. Okay? And so I'll send you the PDF of this later. Right? So, right, we also have what are called reciprocals of the three trigonometric ratios. Now, I just want to add this, that besides the way that I wrote them here, generally, you don't have to write opposite all the time, opposite over hypotenuse in full. No. If you write sine theta, you can write this as equal to O over H. We know what the O stands for, opposite, and the H for hypotenuse. The adjacent is A, it will be, for cos it will be A over what? It will be A over H. Okay? For tan, it will be opposite over adjacent. So you can just write sine theta is got O over H, cos theta is got A over H, tan theta is got O over A. Okay? And remember, the three trigonometric ratios, they are only used if you have got a right angled triangle. Okay? We only use the three trigonometric ratios when you have a right angled triangle. If it's isosceles and it's not right angled, you can't use it. If it's a scalene, you can't use it. Equilateral triangle, you can't use it. Okay? Later, you'll be introduced in grade 11, you'll be introduced to cases where you can apply trigonometry to other types of triangles. Okay, but in this grade, we'll concentrate on the right angled triangle. Okay, so you need to memorize your three trigonometric ratios. Sine theta opposite over hypotenuse, cos theta adjacent over hypotenuse, tan theta is equal to opposite over adjacent. And this is not difficult to memorize. Okay? And this, okay? Now, these three trigonometric ratios, they also have what are called reciprocal functions. Now, the reciprocal functions or just reciprocals, you get them by dividing any one of the three trig ratios by 1. So what I mean is, if you have, say, 1 over sine theta, okay, 1 over sine theta, it's a reciprocal, and there's a name for that. There is also 1 over cos theta, it has got a name. We have 1 over tan theta, it also has a name. Alright, so what I'm going to do, listen, I'll introduce the reciprocals when we do some examples. Okay, so your reciprocals, you get them by dividing the trigonometric ratio. In fact, by dividing 1 by the trigonometric ratio. So what I mean is, 1 divided by sine theta is equal to cosec theta. Okay? Now, cosec is not on your calculator, but you need to know that cosec is the reciprocal of sine theta. So, if you divide 1 by sine theta, you get cosec theta. If you divide 1 by cos theta, you get sec theta. If you divide 1 over tan, you get cot theta.
Always.
Yes. Okay? So, you also need to be aware of it. Right? The reciprocal functions. So, the reciprocal of sine is cosec. The reciprocal of cos is sec. The reciprocal of tan is cot. Fortunately, the reciprocals are only taught in grade 10. They don't appear again in grade 10, in grade 11 and 12. And then, when you get on with maths, they will come back. So, because of your cat's character. So, if you remember the question, then you can ask.
No, you don't answer questions very good. You don't answer questions very fast. Like, I put my hand up and then you wait for 5 minutes.
Yeah, because if I'm explaining something, I need to make sure that I carry on until I'm done with emphasizing. Okay. So, those are your three reciprocals. Okay. So, in the coming days, what you have to do is sit down, memorize your three trigonometric ratio: sine theta, opposite over hypotenuse; cos theta, adjacent over hypotenuse; tan theta, opposite over adjacent. Then your reciprocals, the reciprocal of sine is cosec, of cos is sec, tan is cot. Cot is actually, in fact, you see, cosec, the reciprocal for sine is actually called cosecant. But cosec is just a shortcut. Okay? And second, that's the reciprocal for cos. And then cotangent, that's the reciprocal for tan. Okay? So here is more like the ANT for cosec is not included. The ANT for cosec is not included. The agent in cotangent is not included. No, I'm just giving you extra information. So that you know that these are not like the full names of the reciprocals. Okay? The full names are these three. Okay? It's like this cos. Okay? It's cosine. That's the full name.
Abbreviation.
Maybe you can call it an abbreviation or a shortcut. Okay? Sine must have an E. Tan must have the G the E, the N, and the D. So when you say it as a shortcut, we just say tan, cos, sine. But cos is cosine. Okay? Tan is tangent. The reciprocals too have got their full names. Okay? But we just use shortcut names. Okay? Then there is also a relationship with the adjacent side, the opposite side, and the hypotenuse. So your trigonometric ratios, they are reciprocals. Okay? They can also be written using adjacent, opposite, and hypotenuse. So all you have to do is just swap the corresponding formula for the trigonometric ratio. Like here, the reciprocal for sine theta is cosec. So cosec is going to become hypotenuse over opposite. You just swap the numerator and what? And the denominator. Okay? For the reciprocals, if you want to write them using hypotenuse, adjacent, and opposite, you just swap the formula for the original trigonometric ratios. So cosec will become hypotenuse over opposite. Second will be equal to hypotenuse over adjacent. Cotangent will be equal to adjacent over opposite.
So the reciprocal is for that.
But for these three trigonometric ratios, you just swap the numerator and the denominator of the original trigonometric ratios. So you have got that here. You don't need to copy down, and because I'm going to send you this. Okay? So cosec is got hypotenuse over opposite, sec theta is got hypotenuse over adjacent, and cot theta is got to adjacent over opposite. Okay? Now if you multiply a trigonometric ratio and its reciprocal, the answer that you always get is a 1. So if you multiply the original trigonometric ratio and its reciprocal, you always get 1. So you need to close that. You need to cover the rest. You need to put the other book out. There is a next test.